Today, we re-journeying to the far reaches of our solar system to visit one of its most mysterious and downright weird residents, Uranus. Yeah, get all the jokes out of your system now. Are we good? Okay, because Uranus is seriously fascinating, and it's time this icy giant gets the spotlight it deserves. So, what makes Uranus so special? Well, for starters, it was the first planet discovered with a telescope. Up until its discovery in 1781 by William Herschel, everyone thought there were only 6 planets. Herschel was actually just mapping the stars when he noticed an object that seemed to be moving. At first, he thought it was a comet, but after some observation and calculation, it was confirmed, a whole new planet. Imagine that. The size of our known solar system literally doubled overnight. The name Uranus comes from the ancient Greek deity of the sky, Uranus, who was the father of Cronus, or Saturn, in Roman mythology, and the grandfather of Zeus, or Jupiter. It keeps it all in the family, right? Uranus is the 7th planet from the Sun, orbiting at a staggering distance of about 2.9 billion kilometers. That's nearly 20 times the distance from the Earth to the Sun. It rests so far away that it takes sunlight about 2 hours and 40 minutes to get there. To put that in perspective, it only takes 8 minutes for sunlight to reach us here on Earth. Because of this immense distance, Uranus is incredibly cold. It's not just cold. It's the coldest planet in our solar system. Its atmosphere can dip down to a bone-chilling -224 degrees Celsius. That's colder than liquid nitrogen. You might think Neptune, being even farther out, would be colder, but surprisingly, it's not. Neptune actually radiates more heat than it receives from the Sun, while Uranus radiates almost none. It's a very cold, quiet place. One of the most bizarre things about Uranus is its tilt. While most planets spin like a top as they orbit the Sun, Uranus is basically rolling on its side. It's tilted at an angle of about 98 degrees. This means its north and south poles are where most other planets have their equators. What could have caused such a dramatic tilt? The leading theory is that billions of years ago, a young Uranus was slammed by an Earth-sized protoplanet. This colossal impact literally knocked it over, and it's been orbiting on its side ever since. This extreme tilt leads to some of the most extreme seasons in the solar system. A year on Uranus is long, lasting about 84 Earth years. Because of its tilt, one pole will face the Sun continuously for 21 years, experiencing a very, very long summer day, while the other pole is plunged into a 21-year-long winter night. Then, as it continues its orbit, the poles will transition through 21 years of spring and 21 years of autumn, where the Sun rises and sets more normally. Can you imagine a day that lasts for 2 decades, followed by an equally long night? It's a truly alien concept. Now, let's talk about what Uranus is made of. It's one of the 2 ice giants in our solar system, the other being Neptune. This doesn't mean it's a solid ball of ice, though. Its atmosphere is mostly hydrogen and helium, but with a significant amount of methane. It's this methane gas that gives Uranus its beautiful, pale blue-green color. Methane absorbs the red light from the Sun and reflects the blue and green light back into space. Beneath this gassy outer layer, scientists believe there's a hot, dense, fluid mantle of ices. And when we say ices, we don't just mean frozen water. We're talking about a slushy mix of water, methane, and ammonia under extreme pressure and temperature. And at the very center, there's likely a small, rocky core about the size of Earth. So, it's not a place you could ever land a spacecraft on. You'd just sink into its strange, slushy interior. Speaking of its interior, here's something that might blow your mind. Scientists speculate that deep inside Uranus and Neptune, the immense pressure could be squeezing carbon atoms so hard that they crystallize and form diamonds. And these diamonds, heavier than their surroundings, would then rain down through the mantle. Yes, you heard that right, diamond rain. It's still a theory, but the conditions seem to be just right for it. So while it's a frigid and stormy world, it might also be glittering with trillions of carats of diamonds deep within. Like the other gas giants, Uranus has a ring system, but it's much fainter and darker than Saturn's glorious rings. They weren't even discovered until 1977, quite by accident. Astronomers were watching Uranus pass in front of a distant star, and they noticed the star's light dimmed briefly several times before and after the planet passed by. They realized Uranus must have a series of thin, dark rings. There are 13 known rings, made of dark, dusty particles, probably ice, mixed with some kind of radiation-darkened organic material. They are incredibly narrow, some only a few kilometers wide. Uranus also has a collection of moons, 27 that we know of so far. They're not named after figures from Greek or Roman mythology, like most other moons. Instead, they're named after characters from the works of William Shakespeare and Alexander Pope. You've got Titania, Oberon, Umbriel, Ariel, and Miranda as the 5 largest, and then a host of smaller ones, like Puck, Juliet, and Des. These moons are fascinating worlds in their own right. They are icy, cratered bodies, and some, like Miranda, show signs of incredible geological activity. Miranda looks like it was smashed to pieces and then haphazardly put back together, with huge canyons and cliffs jumbled up against older, cratered terrain. It's one of the most visually striking objects in the solar system. Getting a close look at Uranus has been a challenge. Only one spacecraft has ever visited, NASA's Voyager 2. It flew past the planet back in 1986, giving us all the close-up images and data we have. It was Voyager 2 that discovered 10 of its moons and its 2 faintest rings. The flyby was brief, but the information it sent back completely revolutionized our understanding of this distant world. Since then, we've relied on powerful telescopes, like the Hubble Space Telescope, to keep an eye on it. Hubble has captured images showing faint clouds and storm systems moving through Uranus's atmosphere, proving it's not just a placid blue ball. So what's next for Uranus exploration? Scientists are desperate to send a dedicated orbiter mission, a mission that could circle the planet for years, studying its atmosphere, its rings, its strange magnetic field, and its fascinating moons in detail. A Uranus orbiter is actually a top priority for NASA in the coming decade. Such a mission could help us answer so many questions. Why is the planet so cold? What really caused its extreme tilt? What are its dark rings made of? And what secrets are its jumbled moon, Miranda, hiding? Uranus may seem like a distant, quiet oddball, but it holds crucial clues about how our solar system formed and evolved. Ice giants are actually the most common type of planet we've found orbiting other stars in our galaxy, so understanding Uranus and Neptune could help us understand thousands of other worlds out there in the cosmos. It's a planet that challenges our ideas of what a planet should be. It spins on its side, has seasons that last a lifetime, and it might even rain diamonds. It's a world of extremes and mysteries, just waiting for us to come back and explore. It reminds us that our solar system is filled with more wonders than we can possibly imagine, and there's always something new to discover. Thanks so much for joining me on this journey to the seventh planet from the Sun. I hope you found Uranus as cool as I do, and if you enjoyed this video, don't forget to hit that like button and subscribe for more deep dives into the cosmos. See you in the next one.